This video is recorded to help my students to understand structure in C++. We will use an example. Create a program to help a school to manage its students' information. For simplicity, we assume that a student information includes student's ID, name, and GPA only. The program has the following requirements. First, the program shall be able to add, delete, and search for a student. Suppose you store the student in the fixed array, and shall be able to output all students' information to the screen. We will first do this by using fixed size array, then we will use dynamic array in the next video, then use linked list when we study chapter 13. So this example, we will redo it a couple times. So when you get a problem, you first design, okay? So let's first design, which means we write for this small program, the design, we can just write the sample structure of this project first. Of course, you need to include IO stream, include a string using namespace std. Since you use fixed size array, so you declare constant integer, which is the class size initialized to be 30. If your class size is bigger, then you can change this number later. If you use dynamic array to do it, then you even don't need this one. In the next video, we will see how to do that. So then we declare the struct student. Since this student will have three fields, his name is a string, and ID is an integer, and GPA is a double. Notice, don't forget this semicolon when you declare a structure. Now, you need to write the functions to handle this student struct object. So we will say, first we should be able to input a student. So we notice this is called by reference, right? You will be able to input this student as from the keyboard. Now, input a student from keyboard after chapter 11, students might write this student class as a class is not as a structure. So then we can overload this input operator. Then we should be able to output a student to the screen. Then when we output it, we should not be able to change the student. So we restrict this parameter is a constant. Then output the given student information to the screen. After chapter 11, students might write a student class and overload this output operator. Okay? Then we also should be able to output a collection of students to the screen. This collection of students stored in an array, and the size is how many students stored in this array. In this program, we assume the array capacity is fixed size 30, and this size, of course, will less than equal to 30. Then we should be able to search this given students array with so many students stored inside and search by ID. We will use linear search algorithm. If you find the student whose ID matches the given ID, then you will return the index of that student. If no such a student found, that means no student, his ID match this given ID, then this function should return -1. We also have an add student function and a delete student function. Now, add a student, inside the function, we don't print out any error message. We just return true or false. If add a student successfully, then will return true, otherwise return false. What do I mean add a student successfully? If the student you want to add, but his ID already show up in this student array, that means this student already in the array. We call two students identical if they have the same ID. So if you have the student ID already show up in this array, then you will just return false, will not do anything. Now, if not, then you will add this student to this array and increase the array size. The size, which is not array size, is how many students stored in the array. That size increased by 1. So delete student, the same thing. If we will search for this ID for the student match this given ID. If we find this student, then we will remove this student from the student array. Otherwise, since the student you want to delete is not in the class, so you just return false. Okay, then we will have a menu to allow people choose from the menu to do all those functionalities to manipulate a collection of students. Now we have main function. Then you need to begin to implement those functions. So for the menu, we require you be able to add a student, be able to delete a student, be able to search a student, be able to display all students' information on the screen. Then you will allow people to quit the program. So the menu function I already implemented here. Now, when you write the structure of the program, you will copy all those function heads, okay, to here you want to implement. Make sure don't copy semicolon. Then all those functions you give them as a stable version, which means you implement the function in the simplest way first. Simplest way, if the function is void, you just simply give an empty function body. If the function you need to return an integer value, you simply return some integer value. For this example, I'd return -1 because you've not found the -1. Now, if the function need to return true or false, you can return true or return false, right? Normally we return false, default value of the bool variable. Now, after you write all this, what the benefit to write stubs? Because you can really run your function. You can run your program. Okay. Now, can say build successfully. Since your main function doesn't have anything, so the program end immediately. But this at least tell you your structure of the program is right. Now you begin to implement it. To implement it, you have two ways to do this. Some students like to implement those functions first, then write the main function. Okay. For me, I probably would like to implement the main function first, then implement those functions. Why? After I implement the main function, I have a menu that I can, after did those functions, I can test them one by one. So I would like to implement the main function first. When students implement a function, you should first write the pseudocode. What you need to do? For example, first I declare variables. Okay. Then I will keep doing the following thing. I first display menu. Then ask user to choose from menu. Okay. Then get user's choice. Then you will switch the user's choice. Now, since then this while loop will choice not equal 5, because in the 5 is you will quit. So now look, declare variable, I need to declare integer choice. Okay, that's the first variable I need to declare. You say once you do this, you have low errors. Okay, now then in this choice, I will have case 1. Okay, case 1, I will add a student, then break. Now case 2, then I will delete a student, then I have break. Now case 3, then I will search for a student, then break. Then case 4, right? Then I will display all students information, then break. Then case 5, display the message and quit. So I will say out goodbye. Since case 5 is quit, then break. Now then you have default case, print out the error message, run option, no such option. In menu, please choose from 1 to 5. Okay? And break. Now, you can say you get the structure of this program. Okay? After this main function done, then you just need to begin to do one by one according to what you designed. So display menu, I just simply call menu function. Okay, because I already have menu function, I display menu. Then ask a user to choose from the menu into your choice. Right? Then get a user's choice, saying choice, right? Now, then you switch the choice. If user choose 1, that means you need to add a student. How to add a student? Now, let me put it here. Add a student is case 1. Now, add a student, I need to first get a student information, then add a student. Okay? Now, in order to, in that case, how to get student information? I need to have a student variable. So I declare another variable. First, I need to have a student array, which is, for example, students. Now, this student will have the size, which is class size. That's the capacity. That's student array. Then I need to have another student variable s, which is a single student. Right? Then after I have those two variables, I need to get a student information. I just need to say input a student, because I have the function called input a student. So I can input this student. Okay? After I input this student, then I need to add this student in class. Now, to add a student in class, I need to call the function add a student, right? So based on here, I know I need another variable called size, which is class size. Oh, so this is class size. Class size will equal 0 at the beginning. From beginning, no student at the beginning. So I need to add a student. Now, in this case, so I begin add a student to the class. I say if add student. I call the function, right? This student is the array I have called students, and the student size. Then I want to add the student I just input. If add a student is true, then I say out the student has been added to the class. Okay? Else, why you cannot add a student into the class is because this student already exists. Then you print out the, let's say, the student already in class. No action take. No action taken. That means you didn't do anything. Now, notice I even don't need to know how you implement add student method, but I just need to know what you told me. You say this will add this given student added to the student array and increase the size by 1 if you add successfully, which means the student ID not exist. If the student ID already exists, return false and nothing change. So after I read the description of your method, I already know how to use it. So how to use it? I call the method. If it's return true, I print out a message, my student has been added to the class. Else, that means return false, print out a message, student already in class, no action taken, because that's your method told me. Why return false? Because the student you want to add, his ID is already show up in the student array. That means you will return false and nothing change. Okay? So I can write a main function without knowing how you implement this add student function. That's no problem. Then I will begin delete a student. In order to delete a student, I need to load the student ID. So I need to say cout into the student ID you want to delete. Okay. Now, then I need a variable to hold the ID. Please notice do not declare variables in the switch statement. Okay. So I declare the variable here. So I will have integer ID hold one student's ID. Okay. So I will say in ID. Now, then I begin call the function to delete the student. To call the function, I will use if delete student from this student's array and have size, and I want to delete this ID. Now, if this deletion successfully, cout the student has been removed from the class. Okay. Else, cout no such a student in class, no action taken. Because again, this is because you read his function description, how to delete a student. To delete a student, the student with the given ID has been deleted from the student array. If no such a student exists, nothing change and return false. Otherwise, the student with the given ID is deleted and the size reduced by 1 and return true. Right? So that's what your function will do. So I trust you will implement that way. So I can use this function. Now, if I want to search for a student, then again, I need to know the student ID you want to search for. So I will say cout into the student ID you want to search for. Okay. Now again, I will say in ID. Now then I begin to search for the student. When I search for a student, if you read his search function, says linear search the student array to find a student whose ID matches the given ID. If a match found, the index of that student will be returned. You found a student in this array, his ID match this given ID, then the index of that student will be returned. If no such a student found, then return -1. So I need to hold this return the index first. Remember, we cannot declare variable in switch, so I declare integer index. This is the index of a student in array. In array, that's array hold the students in the whole class, right? So I was index will equal search student. Then I have a students array, and with this size, then I will search for this ID. Okay. Now, if the index equal -1, then you will print out no such a student. No such a student in class. Okay. Else, which means you did find such a student and his ID. So you print out the student found. Information is, since you found this student, right? So you print out his information. Now, to print out his information, you just simply call the function output student. So I will call the function output student. For those student you want to output, which is in the student's array, and his index is this. So you found that the index, right, for the student you want to search for, which match the given ID. Then you print out this student information by call output student function. Okay. Now, if people choose to display all students' information, that means you need to call this function, which is output all the students. Okay, so you just simply call this function. Okay, so you will say output students student. You will give students array size. Okay, then you will output all of them. Now, pay attention. At this point, you still can run your program. For example, if you wish to, you run the program successfully. Of course, then nothing really happen if you do, because your function not implemented. But at least we can check some functionality. For example, I choose 6. Then he say no such option in menu. Please choose 1 to 5. If I choose 5, goodbye. I quit the program. So at least I know at this point my program structure still good. Okay. Now I begin to implement those functions. How to input a student. To input a student, you need to understand when you have a struct s to access the field name, you just use s.name id s.id GPA s.GPA. So in order to input a student, you print out enter students ID, for example. Then you just say in s.id. Now, so s.id is just like a integer variable. If you go back to look at your s, the student structure has 3 fields, right? Name is a string, ID is an integer, GPA is a double. So if you have a student structure s.name to access name, s.id access his ID, s.gpa access his GPA. So same thing, we can say cout enter students name. Okay. Now, student name include first name and last name. Then we'll have the space between. So we use getLine. Okay. I will use getLine cin, then s.name. Now here has something you need to pay attention. It's very easy to get some trouble here. So the best way to do this, before we do any input, we clear the buffer first. So I will use cin. Probably I can put it here to be safe. cin.ignore. I want to ignore some new line character before I call getLine. Okay. Now, ignore new line character in the input buffer. Then I will cout enter students GPA. Then I will cin s.gpa. So this is how to input a student. Then to output a student, of course, I just need to use all those cout, right? So cout, if I want to output ID, s.id, then cout name, s.name. Then I can use cout GPA s.gpa. Now, after those, I can begin to test, because I should be able to add a student now, but I want to display all students. I did not implement this function yet. So let us implement this overloaded function. Notice that you have 2 output students. but they have different argument list. They have the same name and a different argument list, then we call those two methods are overloaded. So the compiler will know which method you call, because when you call the method, you will pass the arguments, right? You based on the arguments you passed, hello, which version is called. So in order to display all the students in the student array, so what I do, I use a for loop, right? Step through the array, integer I equal 0, I less than size, I plus plus. Each time I will output a student information. So I output a student. So this student is SI. That's the student I want to output. After output, I might want to print out a new line. Okay, so I have a space between two students' information, as a spare line between two student information. Okay, so this output all the students. Now it seems like I will be able to input a student, I will be able to output a student, I will be able to output all the student. Now let's be able to add the student first. Okay, do the add student. Now if you give me a student I want to add, the only thing I cannot do it is if the student already exists, right? So I need a search student. So I need to be able to search a student first. Okay, let's do this. I will do linear search. So linear search, I will use the loop for integer I equals 0, I less than size, I plus plus. I go through the whole array, right? If si dot id, okay, matches the given id, then which means I found. So I just return I. If through this for loop I don't return, I return -1. That means not found. Okay. Did I spell it wrong? Probably not. Okay. Now let's say here, this linear search, I step through every element in the array. Okay. If one student, his ID match the given ID, I return the index of that student. If I step through all students in the array, I didn't return, then I return -1, which means not found. Now, let's do this one, add a student to the class. Add a student to the class, I first need a search. If the student is not is in the class already, I just return false. So if search student, I call the search student function. Search this student S with the size with the add the student dot ID, because I only can search by ID, right? Since you want to add this student, so I can get his ID to search through the student array. Say if this ID not equal -1, if the search result not equal -1, which means students already in class, then I just return false. Okay. So if it's not well, let's do this. Equal -1, return false. Equal, no, not equal -1, return false, right? Yeah, not equal -1, return false. So here I need to return true. Okay, if you don't return false, which means you wanted to add this student in, you will be able to add this student in. Okay, so I try to search this given student ID through the class. If I found this ID, that means student already in the class, I return false. If it's not in the class, I add a student to this class. So how to do that? I will let s size, which will equal added. Okay, so I have then I increase size by 1. Add the student to the array, then increase the array the size by 1. Size is how many elements in the array. Increase the size by 1. Then I'll return true. Okay. Now, if I want to delete a student, again, I will search again. If actually I can copy the same thing, right? So I don't have to type. Again, if student equal active 1, this time student not in the class. This time if it's equal active 1, that means I did not find this student, okay? I need to change here to ID because the given argument is ID. If I search this ID is equal, search this student array with this given ID, the result is active 1. That means the ID you want to delete is not in the class. Then I will not do anything, I just return false. Now, the tricky part is here. Now, if it is in the class, what you will do? Which means you did find you did find this ID. So in this case, I did use this ID again. So I probably maybe good idea is declare the index equal this, because I did use this index. Now, if this index equal active 1, I return false. Otherwise, I did use this index to do something. Why? Because this index is the index of the student that you wanted to delete. How can I delete fast? The idea is this. I swap this student with the last element in the array, then I reduce the array, reduce the size by 1, which means the last element is not accessible. Equivalent, it is deleted. So the idea is I swap, okay, this S index with S size minus 1. S size minus 1 is the last element in the S size minus 1 is the last element in the student array. Then I swap the one you want to delete with this one. Then I reduce size by 1. Some people also so I reduce size by 1. Okay, so that means you swap the one to be deleted with the last one. Then now the last one is not accessible, i.e. deleted. That means it's not in your class anymore because your class array cannot access that student anymore. Okay, so this you implement all of this, then let us try to test the program. So we successfully. Now let's try some choice. First, add a student has an Intel student ID. Suppose 1000 Intel student name Tom Cruise. Then Intel student GPA for 3.5. Now student added to the class. Now if you probably want to add one more student, for example, then student ID 1001 time Michael Jackson. If I spelled name wrong, I'm sorry. Then the GPA, suppose he's a good student, then has been added to the class. Okay. Now you can display the all students. You choose option 4. You will say the student ID 1000 Tom Cruise, GPA 3.5, ID 1001 Michael Jackson, and GPA 4. GPA is 4. Now if you say I add one more student, so Intel student ID suppose is 1002, and the student Jerry, Tom and Jerry, and the GPA is 3.95. Okay, now student has been added to the class. If you display the all students, you can say Jerry Tom is here. Now let us try to delete a student. So into the option 2, into the ID you want to delete. Suppose I want to delete the first student. His ID is 1000. Okay? Now he says the student has been removed from the class. How do you know that? Let's display all the students. Now you say the before last student Jerry Tom, since he swapped with the first student Tom Cruise, who will be delayed, then now he become the first student. Why we want to use this method to delete? In this case, the running time is very good. Okay. Now, of course, if you know add and delete are right, then you know your search function should be right. But you still can try. Let's try to search a student. Search a student for ID 1000, which is your just delete. Then he say no such a student in the class. Then I try to search again, ID 1002. Then he will say this student with the ID 1002 is Jerry Tom. The GPA is 3.95. Okay, so let us quick grab this again. So you say when you get a program, do not try to write a code immediately. Understand the question, then you design the program structure first for this small program. In the future large program, we have software engineer process to follow. But for this one, we kind of also follow that process. We design first, understand question, design first, right? When we design, you write the structure of the program. You write down, declare all the functions needed, write a description of the function, write a main function with input body. Then you write all those functions as a stable version, which means if void function, you give an input body, integer, return integer function, return any integer like negative 1, Boolean function, return true or false. So you get the structure of the program done first. Then you begin to add in the code. When you add in the main function, you still design first, write down the pseudocode first, what you need to do. Then when you implement the main function, you really don't need to know how to implement those other functions first, because you just need to know how to use it. Okay? Now, I will upload this example to the Blackboard. If you have any questions, please give me an email.